Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 7, Lesson 4, on identifying exponential functions. So far this unit we've seen inverse functions, but now we're looking at exponential functions, and we can apply that to this. So, we've already learned about this a little bit, but what is an exponential function? Well, when you hear of something growing exponentially, it's not like it just grows like this. Like that. It grows like that. So that kind of makes sense. And this is what the parent function is like. So remember, parent function for a linear function is this. If you make that quadratic, it's this. Cubic function. Whatever it happens to be. So, it is y equals 2, not 2x. It might look like 2x, but it's 2 to the x power. So whatever x is an exponent. That's why it's an exponential function. And you might think, well, why is there a 2? Why isn't it 1? Well, then that would just be the same as y equals x, because whatever x would be would just cancel out the 1, because anything to 1 to any power is what that power is itself, so that 1 doesn't even mean anything. So, that being said, let's see some things about this. It has a vertical asymptote of y equals 0. When we did rational functions, remember the asymptotes, they were things that when you're drawing the line, it can't go through. So, rational function, remember, they look like this. When you have the exponential function, it looks like that. Well, the standard one looks like that. And it has an asymptote at y equals 0. So basically, it can't go through the x-axis. The only way that can change is if we have a transformation, which we'll look at that in the next lesson. It has a y-intercept of 0, 1. That's only for the parent function. It can change based on what transformations you have. And there is no x-intercept because of that asymptote. Once again, that can also change. There can be an x-intercept if there's a transformation. So let's see, table of values. This is just telling you for the standard parent function, based on it, whatever the x is, what would happen with the y. So if we have -2, the y is 1/4. How did we get that? We just take the 2 and we set it to the power of whatever the x value is. So because we have -2, we make it to -2nd power. And we know that if we did that, from our last unit, we know that that would really mean this, which means this, which is how you got that. Because when you have a negative exponent, you can make it positive by putting a 1 over it, and making that the denominator. So you can just see how that works. So let's graph that to see what it looks like. Okay, so we have -2 1/4. So we have a value here. Then we have, well, since we know that we have an asymptote here, I might as well just draw this. Okay. Now what? We have -1 1/2. So you can see, so far, we have little growth, but then it takes off. Once we get over here, you'll see. Then we have 0, 1. That's our y-intercept. We have 1, 2, and then we have 2, 4. And if we were to continue that, we would have 3, 8 also. Because if we did 2 to the 3rd power, we get 8. So we would get that. Try to find that. Okay. So now, and it going this way, we would have values that would get closer and closer and closer to this asymptote, but it would never get there. So I'll just do this in a different color. So that's about what that looks like. So it stays kind of normal, but then once it gets at a certain point, it will just take off like that. So that's what that looks like. So that's what our exponential functions look like, and we'll see the transformations of them in the next video. So thanks for watching, and I'll see you in the next video.